Guys, once again, Ijaz Hidayat is with you with a new talk and with new discussion. Today, we're going to talk about the efficiency of the membrane oxygenator, especially which you're using for the long-term bypass, means like extracorporeal membrane oxygenators. Once we are going to use the membrane oxygenator for cases like ECMOs, or we can say extracorporeal membrane oxygenation. So it is not like for 8 hours. It can be worked for like a couple of weeks, or sometimes it can be a couple of months. So we need to know to understand the efficiency of the membrane oxygenator so that we can change the circuit prior to make any disaster and prior to make any failures of the membrane. So we supply 100% of oxygens to the oxygenators. So to check the oxygenator function, we need to check the oxygen transfer factors. So how are we going to check the oxygen transfer factors? So oxygen transfer oxygen factors, there is a formula we are using. So by using the formula, we can understand and we can get it information that the efficiency of the oxygenator is going to be reduced, or if it is still in a adequate position, so still we get some ideally information. So today we're going to discuss about the oxygen transfer factor equations. So the equation is post oxygen content minus pre-oxygen content into 10 into ECMO blood flow circuit. So it's mean if you want to get the value of the transfer of the oxygen in the membranes, so we need to know about the oxygen content. So to get the oxygen content, so there is a formula, like as I mentioned, the post oxy content minus the pre oxy content into the 10 will be the constant, and into the present pump flow. So the flow which was running by the ECMO, like example you are running almost about more than the 2/3 like in a VV ECMO, so sometimes like a 3 liter 4 liter, and we want to see the efficiency of the membrane is working, is going to be lead down or not. So before that, we need to understand the oxygen content, how to get it, the oxygen content. To get the oxygen content, there is a formula. The formula of the oxygen content is Hb into SpO2 into 1.34 plus PO2 into 0.023. So by putting this equation for the post-oxy and the pre-oxy, you will get the values. So once you get the values, so then you will going to implement the formula, transfer equation formula. So link post-oxy minus pre-oxy. So once you calculate the post-oxy content, you will get some numbers, and then you will get the pre-oxy content, and you will get the numbers. So the post-oxy contents, the blood gas you are getting from the post-oxy, you will take the blood gas and you will get the post-oxy content, like you will get hemoglobin, you will get the saturation, and you will get the 1.34 is the constant, and plus you will get the PO2, and then of course this is the constant 0.023. So we get the values with the help of the post-oxy arterial blood gas and pre-oxy blood gas. So we are going to get the values, then the post-oxy minus pre-oxy into 10 is the constant, into ECMO circuit flow. So ECMO circuit example, if your circuit ECMO circuit is like pump flow is running like a 3 liter or 4 liter, so you put the same value in the formula. So once you put all the values, you will get some numbers. So like example, each oxygenator is having the different gas transfer equations. So like your ECMO flow is running for the quad-S oxygenator example I'm just giving. So your flow was like a 3 liter. So once you get the information of the gas transfer, if at the flow of the 3 liter, if the transfer gas the numbers is below than we required, so it's mean your membrane is going to be failed. If it is above than the number we required, it's mean that your the transferring of the gas through the membrane is adequate, and it will going to work for the long time. So this is one of the matter to check the oxygen transfer factors. There is so many ways to check the membrane's efficiency, like you monitoring the trend of the TMP, transmembrane pressure. So like usually you will get a transmembrane pressures like a 20 to 30 millimeter per mercury. Then on a daily basis you are checking the trend of the TMP. So if the trend of the TMP is increasing day by day, or if the TMPs go like a double or like then 30, so then you have to implement this formula. This formula means transfer equation formulas, which going to help us the how much the gas is transferring through the membranes. As per, so one thing please keep noted in your mind, the time when you do the transfer equations. So the sample which you're getting through the pre-membrane or post-membrane, on that, for example, your patient is on a VA ECMO, so the patient's FiO2 on a 60%, but the time of you going to check the transfer equation, you need to make 100% on your FiO2. So you will get an actual right picture of the transferring of the oxygen through the membrane. So it's mean this formula will going to help about the transferring of the gas through the membrane, or it will help you to change your membrane in a like a elective manner, rather than to you will get in the mid of the night like at the change of the circuit, like if your circuit get failed. So these type of equations going to help you a lot to make a pre-plan to change of circuit or change of the membranes. Hope it is going to help you in your field of perfusion. Have a nice and good day. Take care. Bye bye.